Good afternoon, students. For yesterday, we are started with the topic that is heat transfer. Okay, on that day, we are discussed with the three categories. Okay, and related problems, right? So today, we have to continue with the same thing along with the problems and go for the next topic. Okay, so let us try to answer the following. Okay, so here I write it the example 1. Transfer of heat. Transfer of heat in friction. Friction is by option A, it is convection, and option B, it is conduction, and option C, it is a radiation, and option D, none of the above. So last class, we are seeing the heat transfer and its categories. Okay. So here, this question is related with the topic that is heat transfer. Okay. A transfer of heat in friction is by so the answers you put it in the comment box. If you are known the answer means put it in the comment box. Which one is right? Either option A, B, C, D. Friction. They are given friction. I will give you one clue. The friction process should be carried out in roads. Okay. That is the contact between the road and the vehicle. For the movement of the vehicle at that time, the frictional force, it will be created. So here in this process, it is need a medium. Okay. And there is no particle motion. So that is the clue. Try to answer. It needs the medium as well as there is no particle displacement. Only the heat can be exchanged from one to other. So it is under the category what? So that is the question. Yes, it is option B. Okay, it is option B, that is the conduction. Okay, so it is a very, very simple question. But if you know the concept only, you have to answer. Right? Then second one, in a room heat, in a room heat, is transferred via first one, conduction only. Conduction only. Second one, convection only. Third one, radiation only. And fourth one, all the three modes. So which one is correct? Sorry, we have to put it either A, B, C, D. In a room, heat is transferred via conduction, convection, radiation, and all the three modes. Which one is right? Conduction means it needs a medium. Okay, convection is also needs a medium. Here, room kulara air medium nu irukilla. So air particles are there. So anga air particles mode the radiation is possible. Conduction is possible. Conduction is through the walls. Okay, convection is also there. Okay, which one is right? Radiation மட்டுமே இருந்துட்டு இருக்கலாமா? அப்ப வெளியில இருக்கிற ஹீட் எனர்ஜி அப்படியே ரூம் குள்ளர டிராவல் ஆகும்போது ரூம் வார்ம்தா மட்டும்தான் இருக்கும். There is no cooling process. So change in temperatures இருக்காது. So change in temperature அப்படினாவே it is conduction process, convection process. So all of them are correct. Conduction, convection, radiations. All the three modes are possible. Okay. So option D is the right one. Okay. So it is a very, very simple concept, but we are losing in that one. So if you are not thorough in that specific area, means you have to lose it 1 mark. Okay. So keep in mind that each and every points, it should be very important. Okay, next one. Third, which quantities are needed qualities qualities are needed for cooking utensils? Okay, first option is option A, more specific heat, more specific heat and less thermal conductivity. less thermal conductivity, and B, less specific heat and more thermal conductivity. And option C, it is more specific heat and more thermal conductivity. And option D, it is less specific heat and less thermal conductivity. So last class in the points நான் சொன்னேன், right? So இதுல பார்த்தோன்னே we are neglecting 2 points either. So on that time our mind have registered that either specific heat, either one of them is more and another one is less. Okay, that concept you have to clear. Everyone is clear. So we have to neglect that more, less. It should be cancelled. Okay. So the doubt areas are more or less. Right. So the more specific heat, conductivity process. So conduction process அப்படினாவே high conductivity இருக்கணும். Okay. So more thermal conductivity and less specific heat is the right one. Okay. Conductivity process, it should be increases. Okay. அத வந்து ஞாபகம் வச்சுக்கோங்க. Okay. It should be increases, specific heat is decreases. So option B is the right one. Okay. Very good. Next, we can go for the problems. Okay. So here, write down the problems related with the thermal conductivity formulas. Okay. Steam at 373 Kelvin, yes, passed through a tube of radius. A tube of radius 10 centimeter and length, it is 2 meter, and the thickness of the tube, yes, 5 millimeter, and the thermal conductivity of the material is 390 watt meter power minus 1 and Kelvin power minus 1. So let us now calculate the heat loss. Okay, the heat loss lost per second. Here they are given the outside temperature. Outside temperature is 0 degrees centigrade. Okay. So in that problem, what are all the quantities there are given? What are all the informations they are given? They are given the value for K. They are given the value for K. Okay. And they are given the initial temperature. Okay, that is T1. Here T1 is there and T2 outside the temperature. So it is given in centigrade. So now we have to convert it into kelvins. Okay, so this is T2. Okay, K they are given, T2 they are given, T1 they are given. Okay, and one more thing, time is passed through the radius per second. That is time is 1 second. Heat loss. Okay, the time they are given as 1 second, and for the L, okay, thickness they are given. Okay, then they are asking the value of Q. Okay, so the length we have to calculate Q value. So problems note la copy panikonga. Let us now solve this one. Okay, all right. Next we can go for the solution of this problem. So what is the rate of flow of heat formula? That is Q is equal to Ka into T1 minus T2 divided by L. Okay. So here the heat lost is through the cylindrical surface. Okay. So here in that problem they are given the cylindrical tube. It should be cylindrical, no? The heat loss. Heat is lost through the cylindrical surface of the tube. Okay. Then first you have to write it down the given values. Okay. What are all the given values? That is K1 is equal to 390 watt meter power minus 1 and Kelvin power minus 1. They are given. Okay. Then second one, T1 is equal to, okay, 373 Kelvin and T2 is equal to 0 degree. Okay. Convert the 0 degree into Kelvin. 0 degree centigrade Kelvin convert பண்ணனும்னா என்ன values you should add? Message பண்ணுங்க பார்க்கலாம். Celsius we have to convert it into Kelvin abdina. We have to add 273. Okay, very good. So here it is 0. Okay, so you should add 273 na. It is 273 Kelvin. Okay. Then what about L value? That is the thickness value. 5 millimeter, which should be is equal to 0.005 meters. Okay, 5 into, இது நம்ம எப்படி எழுதுறோம் 5 into 10 power of minus 3 meter. Okay, minus 3 அப்படிங்கும்போது 3 digits forward பண்ணோம் அப்படின்னா we are getting 0.005. Okay. Right. Then T is equal to 1 second. Okay, formulas la நம்மளோட required quantities எல்லாமே இருக்கு. Then what is the remaining thing? That is the area teva. Area. So it is the cylindrical tube. Okay. Right. So cylindrical tube. So here it is a cylindrical tube. So cylindrical tube we are calculating area, which is nothing but length into breadth. So here it is a length and it is a breadth. Okay. So length and breadth you have to need, right? For the circular portion, adoda area it is a radius 2 pi r. Okay. So 2 into pi into r into L value. That is the length value. So here R, which is nothing but the radius of the tube, and which is multiplied by the length of the tube. So yeah, inga length நம்ம multiply பண்றோம். Area is calculated by length into breadth. Okay, so here we can calculate the circular area as well as the length. Okay. So idla what is the value of A? A is equal to 2 pi. R oda values enna kuduthirukanga? It is, what is the value of R? Radius, it is 10 centimeter. Okay, 10 centimeter into, and the length it is 2 meter. So notice that here it is centimeter and here it is meter. Okay, so next step, you have to convert it into meters. So 2 pi into meter centimeter convert பண்ணும்போது it is 10 power of minus 2. Okay, so for 10 power of minus 2 அப்படிங்கும்போது 2 digits forward. So for 0.1, simply we are writing 0.1 meter, right? And here it is 2 meter. So I write it meter square. Okay, then next step, it is 2 into 2, 4. 4 into 0.1, it is 0.4 into pi into meter square. Okay, right? So area oda values எப்படி calculate பண்றதுங்கிறது தெரியுதா? It is clear? Message பண்ணுங்க பார்க்கலாம். Up to this clear? Yes. Ten centimeter, 10 into 10 power of minus 2 meter, 10 power of minus 2 ku we can forward 2 digits before. So for 0.1. Okay, into meter, right? And here it is 2 meter. So meter into meter, it is meter square. So that is the next step. Okay. So this step, I directly substituted here. Okay. 10 power minus 2 na, it is centimeter, and 10 power minus 3 na, it is millimeter. You have to clear. Okay. So 10 power minus 2, it is centimeter, and 10 power minus 3, it is millimeter. Keep in mind. Okay. Okay, very good. Everything, it should be clear. Okay, next step. All our values are there. For the next step, all these values. Okay. All these values are substituted in this formula. Okay. So in this formula, and directly you have to calculate the value of Q. So calculate பண்ணி என்ன answer வருதுன்னு சொல்லுங்க பார்க்கலாம். You have 2 minutes time. So first I write it the formula solution. Okay, so Q is equal to KA into T1 minus T2 divided by L. So here this L represents the distance. Okay, distance between the two ends. Okay. So here they are given the circular areas. Okay, circular areas அப்படிங்கும்போது it is having the thickness. So that we are taking L value is equal to 5 millimeter here. So let us now substitute in this 1 into a formula that is 390. Okay. 390 watt meter power minus 1 and Kelvin power minus 1 into 0.45 meter square into 373 minus 273 Kelvin into 1 second divided by 0.005 meter. Okay. So let us now, the common terms you have to cancel. Okay. Here, plus 1 minus 1, it should be cancelled. And here meter square and it is a meter. Okay, that is 1 cancel. And here minus 1 and here it is a plus 1, it should be cancelled. Okay, then remaining are 390 into 0.4 into pi into 10, that is 100. 373 minus 273, it is 100 divided by 0.005 watt second. So here the left unit are watt second. So we are known that joule is equal to watt into second. So the answer, it should be in joules. Okay, the answer, it should be in joules. So the calculate பண்ணி powers cancel பண்ணி சொல்லுங்க பார்க்கலாம். What is the answer? Okay, radius convert பண்றது already நம்ம பண்ணிட்டோமே. 10 centimeters we are converted into meter, that is 0.1 meter. Okay, then 0.1 meter into 2 meter, which is multiplied. Okay, so meter into meter, again meter square. Okay, so somebody is asking this question, that is 10 centimeter into 2 centimeter. Okay, so here 10 into 10 power of minus 2 meter into, okay, 2 meter. So let us now 10 power minus 2 now, it is 0.1 meter into 2 meter. For the next step, 0.1 into 2 meter square. Okay, so in the answers previous நம்ம எழுதணும். Okay, right on. After this clear? So சீக்கிரம் solve பண்ணுங்க பார்க்கலாம். 390 into 0.4 into 10 hundreds divide by 0.005. Okay. So directly I have to write it the answer. You have to check it. 98 into 10 power 5. 98 into 10 power 5 joules. So that is the right answer. Okay. Check பண்ணிட்டு next classல வரும்போது work out பண்ணிட்டு எனக்கு சொல்லுங்க. Okay, so this is the answer. Okay, next we can go for the another problem, that is exercise number 2. Here two vessels of a different material point correct place பண்ணுங்க பார்க்கலாம். That is the 98, that is 97.68. We have to approximate, that is 98. Yes, very good, Sonia. And material are identical in size. And wall thickness. They are filled with equal quantities. Equal quantities of ice at 0 degree centigrade. If the ice melts completely in 10 and 25 minutes. 10 and 25 minutes respectively. Then compare the coefficient of thermal conductivity of the materials of the vessels. Okay, so that is the problem. So here they are taking two vessels, okay, which is different types of material. So different type of materials, we need a clue. Okay, we have a clue. What is it? Different materials, Navi, which one is varied? Formula la change agade. Our formula is Q is equal to K into A into delta T. It is rate of change of Q by T is equal to here delta T divided by L. So this is the formula. Okay. So idhila two vessels of different materials which value is going to change? Yes, very good. K value is changed. Okay, very good, Shanmuga Priya. And K value is nothing but thermal conductivity of a material, right? Then what is the another information? Identical in size and wall thickness. Size and wall thickness the length value, it should not be varied. Length change agadu. X distance change agadu. That is the thickness change agadu. Then area oda values A change agadu. Only the thing temperature variation so dear. Okay. They are filled with equal quantities of ice. Rendu vessels we are taking ice. Okay. Ice at the temperature 0 degree. If the ice melts completely in 10 seconds, 25, 10 minutes, it is how much it should be varied. And 25 minutes, how it should be varied. Okay. First one, 10 minutes, it should be melted. And the second one, it takes 25 minutes. Okay. Habdi change aga thermal conductivity oda values every vary agum. Abdintrada question. Okay. So now go for the solution. So here we are taking two vessels. Okay. So here one vessel and here another vessel is here. So each of them having different kind of thermal conductivity, that is K1 and K2. Then the identical in size, they are having the same area and thickness and length. Okay. Rendu vessel kume area, thickness and length value, it should be same. So here A represents the area and X represents the thickness and L represents the length. Okay. These quantities are same. Identical means same. Identical means it is same. Okay. Then the variation in temperature. Ice melting temperatures, they are given. Okay. So here we can place it the ice. Okay. So is the first vessel in the ice complete melt agradhukku it takes a time, that is 10 minutes. Okay, 10 minutes. Then second one in the material, in the vessel, second vessel, we are placing the same quantity of ice, but it melts. Okay. So at what time it should be completely melts means it is 25 minutes. Okay, 25 minutes. So ipa 10 minutes இது மெல்ட் ஆகுது, இது 25 மினிட்ஸ்க்கு மெல்ட் ஆகுது. அப்படி சேஞ்ச் ஆகும்போது K1 K2 ஓட ரேஷியோ என்னவா இருக்கும்? That is the question. Okay, that is the question. Let us now relate this one. So here K1, here it is K2. The change in temperature, we have to take it as T1 and T2. For the first vessel, we are taking T1, and the second vessel, we are taking it as a T2 value. Okay, so at the ends, we are taking it is theta 1 and theta 2, and here also theta 1 and theta 2. Okay, so I write it the expression for both of them. ரெண்டு வெசலுக்குமே நம்ம rate of heat flow நம்ம எழுதுறோம், that is Q by T. So Q is equal to K into, for the first material you put 1, that is K1 A into the temperature variations theta 1 minus theta 2 into T1. Okay, Q by T la இருக்கிற அந்த T1 நாம இங்க மேல கொண்டு வந்து எழுதி இருக்கிறோம். Okay, then it is L, which should be is equal to K2 A into theta 1 minus theta 2 into T2 divide by L. So இதுல என்ன quantities எல்லாம் காமனா இருக்கோ அதெல்லாம் நம்ம என்ன பண்ணலாம், neglect பண்ணிடலாம். Okay, so like here there is no change in area, there is no change in L, and initial temperature and final temperature, it should not be varied. Okay, so separately we are taken the temperature alone, there is no change in temperature between the ends. Okay, so we need not worry about this ones, A theta 1 minus theta 2 and A L we have to neglect பண்ணியாச்சு. So this equation becomes K1 T1 is equal to K2 T2. Okay, from that expression we are writing K1 by K2. So problem la enna கேட்டிருக்காங்க, compare the coefficient of thermal conductivity of the materials of the vessels. Comparison 1 and 2. So K1 by K2 is equal to T2 divided by T1. So here T1 oda value it is 10 minutes, no, it is 10 minutes, and T2 oda value it is 25 minutes. Okay, so let us now substitute in this, that is 25 minutes divided by 10 minutes. Okay, you should cancel, it is 5 by 2. So the answer is 5 by 2. So that is the ratio. Okay, ரெண்டு vessels எடுத்துக்கிறோம், ரெண்டுமே same type of materials கிடையாது, different types of material. So அதனால அந்த particular ice melt ஆகக்கூடிய timings வந்து it should be changed, time vary ஆகும். Okay, so அந்த change in time mention பண்றதுக்காக தான் we are having T1 and T2. Okay, timing vary ஆகிறதுனால தான் we are take it as a T1 T2. Okay, so here small T1 represented as a timing. Okay, capital T it is stands for the temperature. Okay, now what is clear? Yes, so the ratio is 5:2. Okay, I didn't give any options, so direct solution only you have to write. Okay, for the first step, first problem we have to check it, the answer, that is 98 into 10 power 5 joule. That is the answer. Okay. So problem 1 and 2, it is clear, children? Put it in the comment box. Problems 1 and 2, it is clear? Yes. Okay, thank you. Next, we can go for the next topic, that is junction temperature. Junction temperature. What is meant by that junction? எல்லா பாயிண்ட்ஸும் ஜாயின் ஆகுறது தான் நம்மளுக்கு என்னது ஜங்ஷன் அப்படின்னு சொல்லிட்டு சொல்லுவோம். So here we are take it two rods. Okay, here we are take it two rods. So this is our junction area. Okay, the center part, it should be the junction area. Okay, here for the first material having a thermal conductivity K1 and here it is K2 and the area it is same mark mari we have to choose the okay area it should be same area and here for the first material or the length it is L1 and the second material or the length it is L2 and the temperatures are T1 and T2. Okay, so in that problem they are given two rods. The combinations of two rods are given. Okay, rendu rods kudutittu at the junction what will be the temperature abin they are asked. They are going to ask. Appa enna values eppadi calculate pandrathu abina, there should be one formula is there. Okay, T is equal to K1 T1 L2 plus K2 T2 L1 divided by K1 L2 plus K2 L1. Okay, so junction temperature calculate பண்றதுக்கு என்ன formula அப்படினா இதுதான் formula. Okay, ரெண்டு conductors கொடுத்துட்டு okay, ரெண்டு conductors if you are combined it together, okay, it forms a junction. So here this is a junction, the junction area. So combine ஆகும்போது நம்ம அதோட there should be change in temperature. So automatically temperature it should be varied. So but temperature vary ஆகும்போது அந்த particular junctionல எவ்வளவு temperatures இருக்கும் அப்படின்றத we have to calculate. So அதுக்கு we are using this formula. Okay, suppose in this case the length L1 L2 it should be equal அப்படின்னா the formula it should be changes. L1 and L2 அப்படிங்கும்போது it should be take it as the identical one. So for identical one அப்படிங்கும்போது here area வந்து identical area வந்து it should be the sameன்றனால நம்ம ஃபார்முலால ஏரியாவே நம்ம கொண்டு வரல. Okay, so அதே மாதிரி length it should be same அப்படிங்கும்போது இந்த ஃபார்முலாலயே என்ன பண்ண போறோம், இந்த L1 L2 விட்டுட்டு ரிமைனிங் மட்டும் நம்ம எழுத போறோம். Okay, so இது எப்போ length ஓட values it should be equal அப்படிங்கும்போது L1 is equal to L2 அப்படிங்கும்போது அந்த பர்டிகுலர் ஜங்ஷன் டெம்பரேச்சர் கால்குலேட் பண்றதுக்கு என்ன ஃபார்முலா அப்படின்னா K1 T1 plus K2 T2 divide by K1 plus K2. Okay. So junction temperature calculate பண்றதுக்கான formula இதுதான். Okay. So here K na என்னன்னு தெரியும் K which is nothing but thermal conductivity of a material and T1 அப்படின்றது இதோட temperature of the first one. Temperature of first body. So in the body when it is made up of iron material or whatever the material, எந்த material வேணாலும் இருக்கலாம். Then length வந்து we are taking for the first one. So it is length. And here A represents the area of cross section of the material. Okay. So let us now go for the problems related with the formula. So இந்த ஃபார்முலாவை நம்ம எப்படி யூஸ் பண்றது அப்படின்றத ஒரு எக்ஸாம்பிள் we are going to see. Okay, so problem here two rods A and B are connected. Okay, I have taken A and B rod are taken. So both of them are connected. So this is our junction. Okay, so here the temperature it is T1 and it is T2. T1, T2 value it is 30 degree centigrade. And here T2 it is 60 degree centigrade. And distance between the two rods here for the first one it is 1 meter. And for the second one it is 2 meter. Okay, so now I need the junction temperature. Okay, so here I can given the value for Ka, that is for the first one 100 watt by meter degree centigrade, and Kb it is 50 watt by meter degree centigrade. Okay, so now write it the question. At the junction, what is the temperature? At the junction, what is the temperature? So this is the question. So here I can give 4 options, that is 30 degree, and B it is 32 degrees centigrade, and for C it is 36 degree centigrade, and for D it is 41 degree centigrade. Okay. So இப்போ இதுல நம்மளுக்கு ப்ராப்ளம்ஸ்க்கு இந்த பர்టిక్యులர் ப்ராப்ளம் வொர்க் அவுட் பண்றதுக்கு ஃபார்முலா நம்மளுக்கு ஆல்ரெடி தெரியும், இப்போதான் நம்ம பார்த்திருக்கோம். So அந்த ஃபார்முலாவுல we have to substitute. Okay, formula write பண்ணலாம். So let us now go for the solution. Solution of this problem. So here what is the formula? T is equal to K1 T1 L2 plus K2 T2 L1 divided by K1 L2 plus K2 L1. Okay, so let us now substitute all the values here. For the K1 it is 100, and T1 is 30, it is 2 plus 50 into 60 into 1 divide by 100 into 2 plus 50 into 1. Okay, so if I solve பண்ணுங்க பார்க்கலாம். Let us now solve in this one. எவ்வளோ டிகிரி டெம்பரேச்சர்ஸ் வருதுன்னு சொல்லுங்க பார்க்கலாம். Yes, very good. It is option C. Yeah. So இத சீக்கிரமா சால்வ் பண்ணுங்க பார்க்கலாம். Yes, Vidya, it is good. Yes. Now we are multiplying all these values. So here 1, 2, 3 zeros. You put 3 zeros. 3 into 2, 6 plus here 2 zeros and 6, 5, 30 divide by it is 200 plus 50. Okay. So here 9,000 divide by 250. So here it is cancelled. Okay. Next we can go for 25. That is 900. It is 3 times 75. Here it is 150 for the 6 times. Okay. So here the answer is 36 degree centigrade. So this is option C is the right one. Last வந்துட்டு class வந்துட்டு you are asking which lesson is this. Okay, for the physics class, for the upcoming classes you have to come in first one. Okay, try to okay, try பண்ணியாச்சா எல்லாரும்? Try to fast children. Okay, all are getting the options. Yeah. Okay, very good. Next. So this is a very easy problem. Suppose they are asking in the toughest one. We are taking this as an example. So it is not a tough one. Suppose 3 or 4 bodies are connected. Say for 2 or 3 iron rods are connected and they are asking the heat transfer between the 3 or 4 or 5. Okay. So on that time, how it should be solved? We are going to take one example. Okay. So let us now calculate the same junction temperature for this problem. So here 3 rods are taken. Okay. So at the temperature, it is initially 80 degrees centigrade. And this is for 2K. And this is for K. And this is for 3K. The ending temperature it is 20 degree and it is 60 degree centigrade. Okay. Here 3 rods are connected. Okay. So this is the first rod. And this is the second one. And this is the third one. Okay. So now what is the question? The 3 rods are meeting. That meeting point, we are called it as a junction, right? Junction point la what would be the temperature? Okay, that is the question. So here the rate of flow of heat or the value it is 2 Kelvin. Okay, that is 2 by T of 1 and here The rate of flow of heat or the values we have to take it as Q2. And here it is Q by T, that is 3. Okay. So இதுவரை நம்ம பார்த்தது எல்லாமே இதோட starting temperature and ending temperature, that is theta 1 and theta 2. Here also theta 1 and theta 2. Here also theta 1 and theta 2. So the temperature variations is here. So if you are connecting this one, okay, so it should be maintained at some temperature. So இதுக்கு ரெண்டுக்கும் நடுவுல there must be some temperature variations. Okay. So here the heat energy is transferred through this rod. Initially it is 80 degree and finally it is T at the junction temperature T. அப்படின்னு சொல்லிட்டு we are taken, and the T temperatures la irundhu again it should be when the heat energy is traveled through this rod, travel பண்ணும்போது there must be change in temperature. So for temperature T ன்றது என்னவா convert ஆகுது, it is 20 degrees it is going to convert. அதே மாதிரி இந்த junction temperatureல இருந்து இன்னொரு conductorsல the heat energy transfer ஆகும்போது it should be increased, that is 60 degree centigrade. So இப்படி ஒன்னா இருக்கிறது ஒரு ராட்ல இருந்து கிடைக்கக்கூடிய எனர்ஜி இட் should be splitted into 2. So அப்ப splitted into 2 அப்படிங்கும்போது ரெண்டுமே ஈக்குவல் அமௌண்ட் ஆஃப் எனர்ஜியா இருக்குமா or it should be different இருக்குமா? That is the question, first one. So first we have to check it whether the two rods are having equal amount of the rate of flow of heat. Check பண்றோம். Okay, right. So அப்ப check பண்ணும்போது இங்க check பண்ணுங்க, it is 3K and here it is K. So which one is, it should be larger? It is here, it is A, and here it is B, and here it is C rod. Okay, which rod having higher amount of rate of flow of heat? எதுக்கு அதிகமா இருக்கும், எந்த ராடுக்கு? Yes, it is 3K, that is B ராடுக்கு தான் heat energy ஓட heat transfer அதிகமா இருக்கும் comparing to C. Okay, so change in temperatures anga varudhu. So now we are taking the temperature variations for the first rod we are taking it as delta T1, and the second rod we are taking delta T2, and here we are taking delta T3. So either vachu we have to construct the equation. Okay, right? So in this rod, 3 rods are having equal dimensions. Okay, equal dimensions, I mean they are given equal dimensions. Equal dimensions அப்படினாவே the length, area, length and area it should be same. Length area equal dimensions அப்படிங்கும்போது length and area, length and area are same. என்னவா இருக்கு, it should be same இருக்கு. So நம்மளோட ஃபார்முலா என்ன, Q is equal to K into A into delta T divided by L. So இதுல எது சேஞ்சஸ் இருக்காது, that is A and L. So இத பத்தி நம்ம கவலைப்பட தேவையில்லை. So Q is equal to remaining என்னலாம் இருக்கு, K into delta T. Q is equal to K into delta T. So இத வச்சுதான் நம்ம ஃபார்முலா construct பண்ண போறோம், K into delta T. Okay. So next go for the solution. நம்மளுக்கு first thing you have to find it the value of Q of T1, Q of T2 and Q of T3. இதோட values we have to find it. For Q க்கு நம்மளுக்கு values தெரியும். So இதுல இருந்து we have to substitute and solve it. So எப்படி solve பண்றதுன்றத பார்க்கலாம். So here for the first rod, the rate of flow of heat, we are take it as a Q by T of 1. Okay. So in the first rod la இருக்கிறதோட எதோட கனெக்ட் ஆயிருக்கு? செகண்ட் rod and third rod. First rod ஓட flow of energy, it should be shared by 2 and 3. So for sharing அப்படிங்கும்போது we are adding. So Q by T2. And here it is Q by T3. Okay. First rod la irundhu it should be splitted. Okay. First rod la irundhu it should be splitted. 1, 2, 3. So we are adding 2 and 3. Okay. Right. Ipo formula la irundhu previous case நம்ம என்ன determine பண்ணோம்? Q is equal to K into delta T. So இப்ப இந்த Q ஓட values substitute பண்றோம். Q by T நம்ம என்னவா எடுக்கிறோம்? It is K1 delta T1. Okay. Q is equal to Q of 1, it is K1 delta T1. So similarly Q2, it is K2 delta 2. And Q3, it is K3 delta 3. So இத formula substitute பண்ணிக்கலாம். Okay. So here time is not an important constraint. So அதனால இந்த T ஓட value நம்ம mind பண்ண தேவையில்லை. Okay. So directly I have to write it the value for Q1, Q2 and Q3. So for K1 into delta T1 is equal to K2 into delta T2 plus K3 into delta T3. So we have to substitute the values of K1. What is the value of K1? They are given, it is 2K. And K2, it is K. And K3, it is 3K. Okay, let us now substitute all the values here. So here delta T, which is nothing but it is the temperature difference. Temperature difference, if the temperature difference is calculated from high temperature to low temperature. Okay, keep in mind that it is high temperature to low temperature. For taking the first rod, okay, what will be the initial temperature and final temperature? Okay, that is the delta T1 order values. So here 2K is what? For K1, it is 2K. So let us now write it the value for K1, it is 2K. Then what about delta T1? Delta T1 is the temperature difference between the first rod. It is 80 ko, it is T ko. Okay, so 80 minus of T is equal to. So similarly K2 oda value, it is K into. For the second rod oda temperature at the junction oda temperature na, it is T. Adoda final temperature na, it is 20. So T minus 20. Idu valum potachu. Right. For the third rod, what is the value of K3? It is 3K into temperature difference in it is T and 60 degree. Okay, so T and 60 degree abdingumbodhu, if you comparing the first one, either 80 degree solliyachu, 80 degree la irundhu T temperature ku flow agudhu. It is the first rod. And third rod பாத்தோம் அப்படினா, it is T la irundhu 60 degree. So T la irundhu 60 degree. Here it is 80, it is 20 and it is 60. So here the temperature junction temperature, it is T. Okay. So the temperature variations for the first one is between 80 to T. This is for the first one. And for the second one, it is between this one. And for the third one, it is this one, T and 60 degree. So either T temperature and 60 degree temperature. Okay. So which one is larger? Here 60. So we have to take it 60 as the first one minus of T. Okay. So in the part you have to rightly enter the temperature variations. Temperature variations high to low போகும்போது நம்மளுக்கு values நம்ம subtract பண்ண போறோம். So அதுக்காக தான் we are taking this condition now. Okay. So next one, we have to solve this one now. So for solve பண்றதுக்கு we are just multiplying all the values. Okay, so here k oda values ellame iruka. So it is k oda values. So commonly you have to neglect. So for 160 minus of 2t is equal to t minus 20 plus 180 minus 3t. Okay, so now cancel all these points. Here it is t plus plus 180 minus 20, it is plus 160 minus of 3t. And here 160 minus 2t. So the commonly we are neglecting 160. And here we have to send it the t into the left side. So minus of 2t minus of t is equal to minus of 3t. So all the 3t's are cancelled. Minus of 3t is equal to minus of 3t. So here all the values are get cancelled. So t oda value, it should be equal to 0. So at the junction la evlo temperatures irukum, it should be 0 temperature. Okay. Okay. Yes. Very good. Many of them are correctly answered. Up to this clear, children? Yes, very good. So இந்த மாதிரி problems work out பண்றதுக்கு confirm தெரிஞ்சிருக்கணும். Okay, so the temperature difference, temperature gradient வந்து we have to take it a positive values அப்படின்னா high to low. இதுவே temperature gradient ஓட values negative இருக்கு அப்படின்னா low to high எடுத்தீங்க அப்படின்னா it should be negative. So அதனால எப்பவுமே நம்ம high values இருந்து we have to choose for lower value. Okay, so இதுல t ஓட values it should be greater or 60 values it should be greater. T degree centigrade it should be greater or 60 degree centigrade it should be greater. T 60 அப்படினு பாக்கும்போது 60 தான் greater. So அதனால இந்த last caseல மட்டும் என்ன பண்றோம், 60 minus of t நம்ம போட்டுக்கிறோம். Okay, up to this clear? Yes. So here, so in that problem, they are given that temperature variations, that is delta T1 oda value 80 la irundhu என்னவா decrease ஆகுது, it is T decrease ஆகுது. Okay, right. So the temperature difference is between 80 and T. Okay, for the second case, the temperature difference is between T and 20. So for T and 20, okay, T and 20. And this one, so here it is T minus of 60. Okay, so comparing to the values, that is K, 2K, 3K. So இதுல 3K ஓட values larger இருக்குது அப்படிங்கும்போது we are taking high temperature. Okay, high temperature, that is a 60. So that we have to choose in the last one alone 60 minus of T. Yeah, for the second rod 20 minus of T போடக்கூடாதா? போடலாமே, ஏன் போடக்கூடாது? அது single rod இருந்தா we have to do that. இப்ப அந்த heat energy can be splitted into 2க்கும் 3க்கும் 2க்கும் 3க்கும். Simply we are taking the example here. One apple is there. Okay, so if you cut it equally na, there is no problem. Okay, I cut it into 3 pieces. Okay, I cut it into 3 pieces. 1, 2, 3. Okay, so in the portion it should be large, and second and third portions it should be very small. So இதுலயே இந்த second and third portion நான் ஈக்குவலா கட் பண்ணாம unequal கட் பண்றோம். Okay, unequal கட் பண்ணும்போது the third part it should be greater அப்படின்றதுனால மட்டும்தான் we are take it 60 minus of T. இதுவே நம்ம ஈக்குவலா கட் பண்றோம் அப்படிங்கும்போது, இங்க ஈக்குவலா கட் பண்றோம் அப்படிங்கும்போது we are taking the K value, here also K value, and here also K value, na, there is no problem. Okay, here this value is K and here this value is 3K. Okay, the rate of flow of heat or value, it should be entirely different for different rods. Okay, so for different rods la K1 K2 oda values change ஆகும்போது automatically heat flow oda values நம்மளுக்கு it should be changed. So for temperature variations நம்மளுக்கு changes தான் இருக்கும். So இத compare பண்ணும்போது 2 and 3 compare பண்ணும்போது இதுல தான் the final temperature it should be maximum. So இதுல அந்த அளவுக்கு எக்ஸ்பெக்ட் பண்ற மாதிரி டெம்பரேச்சர் வேரியேஷன்ஸ் ரொம்ப ஹையா போகாது. சோ அதனால we have to take it as T minus 20 as such அப்படியே எடுத்துக்கிறோம். ஓகே, சோ ஒரு பெரிய அளவுல சேஞ்சஸ் இருக்குது அப்படின்றதுனால மட்டும்தான் நம்ம தேர்ட் ஒன்ல we have to choose 60 minus of T. ஓகே, சோ இந்த இடத்துல இந்த டிஃபரன்ஸ் கண்டிப்பா தெரிஞ்சிருக்கணும். தெரிஞ்சா மட்டும்தான் நம்மளால ஒர்க் அவுட் பண்ண முடியும். Okay, up to this clear, children? So இன்னைக்கு போட்ட ப்ராப்ளம்ஸ் எல்லாமே என்னால ஒர்க் அவுட் பண்ண முடியும், எனக்கு ஈஸியா அண்டர்ஸ்டாண்ட் ஆகுது அப்படின்றவங்க ஒரு லைக் கொடுங்க பார்க்கலாம். தட் இஸ் வீடியோல வர சாட்டிங்க ஒரு லைக் பண்ணுங்க. ஓகே, எஸ், thank you for your cooperation. Thank you, children. Meet you on tomorrow. So the small request for the physics class, all are assembled here by the concerned time. Okay, so time க்கு எல்லாரும் கரெக்டா assemble ஆகுங்க. So in between ல வராதீங்க. Okay, thank you.